All right, Geometry Notes 1.3. We're still going to be working with lines and line segments, and today we're also going to talk about middle, so the middle of a line, the midpoint formula, and we're going to talk about the distance formula, how to find the length of a line or segment. So first of all, we have to talk about the difference between and in the middle and midpoint. So to do that, we want to talk about the bisector. All right, so the thing bisector, so think of again the prefix bi means two, and then sector is in sections. So the bisector of a segment is the line that is going to divide the segment into two congruent segments. So that word bisect is very important because it is a lot different than when we talked previously about the word between, that just means in the middle, and if something is being bisected, that means it's being cut exactly in half. So let's look how this would work in a scenario with some variables. In each diagram, M is the midpoint of the segment. Find the indicated length. So what happens is when a segment is being bisected, it's being bisected at its midpoint. So the midpoint here, this is actually, yes, this is the middle. And if it is the middle, then these two pieces becoming congruent. And remember, we talked about before, to mark segments congruent, you use these little tick marks on the line. So those are going to become very important all year long. You're going to really need to pay attention to the diagram and the markings on the diagram, because if those little marks are not there, then those pieces are not equal. That M is not in the middle. As much as it may look like it is, that M is not in the middle unless those two little dashes or tick marks are on the lines. So since we know that, okay, they told us M is the midpoint. So again, I talked last time about the proof has to be in the pudding. You have to know something. You can't just assume it. So they told us that yes, M is the midpoint. So since we know that it's the middle, on the last video, we talked about that if you have congruent segments, so we talked about this, if we have congruent segments, then we know that those segments have equal measures. So this whole postulate applies to this line segment over here. We know that these segments are congruent because that's what these tick marks tell us, that XM is congruent to YM. So if they're congruent, then they have equal measures. So XM is going to be equal to YM. Well, we have to find the actual length of XM. So since they have equal measures, then what you do is you're going to take these two expressions and you're going to set them equal to each other. So this is what I was referring to when I was telling you that if you don't know the definitions, you're not going to be able to finish the problem with the algebra that needs to be applied to it. So if you don't know what a midpoint is, you're not going to be able to set this formula up, this equation up correctly in order to find the right answer. So now from here we would solve this equation. We probably maybe a little rusty on this because you haven't done it all summer long. So just some little tips that if you're solving an equation and it has a variable on each side, this one that's by itself, you don't move it. I always say, oh, it's all lonely, okay? You've got to bring its friend over to it so that it can have some company. So to move anything from one side of the fence to the other, you have to do the opposite. So you have to subtract x. Now those cancel, bring down the 6. 3x minus 1x is 2x. Now we have to get x by itself. Remember, that's our ultimate goal, so we have to get rid of whatever is attached to it. We got to do the opposite operation to cancel out these 2. So this is 2 times x. So to get rid of it, you got to divide. Now these cancel, so all you have left is x, and here you have 6 divided by 2, which is 3. So your x is 3. Now, another thing you've got to get used to in geometry is we don't just solve for x a lot of the times. Like in algebra, all you did was find x. Well, in geometry, you've got to find x and you've got to do something with it. So what we have to do is we have to make sure we read this question again. It says find xm. So x equals 3 is not a length. We have to find the length of xm. So we've got to take that 3 and we're going to plug it back in over here. So then we would have 3 plus 6. So that means the length of xm is 9. So that is your final answer. All right, so a segment bisector does not have to be a line. It can be a point, just like we said, a midpoint. It can be a ray, a line, a segment, or a plane that intersects the segment at its midpoint. So all that's saying is that if you have a segment, okay, it can be bisected by another segment. Okay, if you had a segment, it could be bisected by a ray. So if we could have a ray extending out here, that could be another scenario. So it does not have to always be a line that cuts something in half. Let's look at this example. Line L bisects the segment, find the indicated length. There's that important word again, bisect. You have to know what that means. Luckily, the picture is already marked for us. Sometimes it won't be marked. They'll just give you that it bisects, and it will be your responsibility to go ahead and mark. So since L is the bisector, I know that these segments are congruent. Well, if they're congruent, they have equal measures. So we have to find AC. If AB is 6, well, if this side is 6, we know these are congruent, so that is 6. So the whole thing is 12. The midpoint formula is actually used when the line or segment is on the graph and you want to be able to find the coordinates of the midpoint. So actually find where on the graph the middle of that line is. So what you're going to do is, it's actually a formula that's on your star chart. So to find a midpoint of a segment, you're going to calculate the average of the x-coordinate and of the y-coordinates of the segment. So like I said, this is a formula on your star chart, so you don't have to worry about memorizing it. The midpoint formula is you add your x's and divide by 2. So that's the average. Do you see here over here it said calculate the average. Well, the average is when you add up all your pieces and then you divide by how many pieces you have. So we have 2 x's, we're going to divide by 2. You also have to do the y's. So you're going to add your y's, y1, y2, and divide by 2. So that's the midpoint formula. We always start with the formula. Okay, the formula's got to be there. You got to be there to get credit on work that you do. So in an example here, find the coordinates of the midpoint of the segment with the given endpoints. Here are 2 points that are on a graph. You don't need graph paper to do this, but basically you have a segment that's on a graph, and here's R, and the coordinates of R are 3, 1, and then somewhere on the graph is S at 3, 7. So what this question is asking you is, where is the middle? So all you're going to do is plug the coordinates into this formula, just so we can kind of refresh our memory here. Remember this ordered pair, all ordered pairs are in the form of x comma y. So this one's going to be x1 and this is y1, x2 and y2. It really doesn't matter which one is 1 and which one is 2. Like R does not have to be x1, y1. You can flip it because over here we're just adding, and so when you add, it doesn't matter which one comes first. So now we're going to take this and plug it in. So midpoint equals add the x's. So you have x1 plus x2 divided by 2. Then add the y's, 1 plus 7 divided by 2. The thing you have to remember here is that we have to, before we can divide, we have to simplify this stuff on top. You have to do the top first. Okay, so if you're using a calculator, you have to do 3 plus 3 and hit enter and then divide it by 2. It's got to be two totally separate operations. So we'll do the top first. So 3 plus 3 is 6, and we're still dividing it by 2. 1 plus 7 is 8. We're still dividing it by 2. Now the last step is you divide. So 6 divided by 2 is 3. 8 divided by 2 is 4. So 3, 4 is the middle of that line. So you know on this line there's a middle, and it is at the coordinates of 3, 4. And that's midpoint. The next thing is distance. So we can actually find the length of a segment. So the distance formula is used to calculate the length between two endpoints. Let's get rid of that. All right, it is used to calculate the distance between two endpoints, and distance is also known as the length of a segment. Distance and length, and this is a big thing of mine, guys, they are never negative, and we talked about that a little bit before when we were using the number line. All right, distance and length are never negative, because when you travel backwards, you're still traveling. Your feet are still moving. You're still covering ground. These are a couple of these words you have to get linked in your mind as well. Distance and length, okay, they have to be connected, because some questions are going to say, what is the distance between the 2 points? Other ones are going to say, what is the length of the segment? So distance and length, all right, they're going to be calculated the same exact way by using the distance formula. This formula is a little crazy. So the distance formula is the square root of, and again, this is on your star chart, so you don't have to memorize this. It's x2 minus x1 squared plus y2 minus y1 squared. There is a lot of room for error when you use this formula, so you have to be really, really, really careful when you are doing this formula, because if you're not careful, then you're going to make some kind of silly mistakes somewhere, and we just don't want you to do that. Now, let's look at this example. What is the approximate length of RS with endpoints R at 3, 1 and S at -1, -5? So again, we don't need a graph piece of paper right now, because all we're going to do is this distance formula. I am going to show you when we get to class another way to do this, so you can use the graph paper to kind of help you out. So again, you always start with the formula, what we have written there, then you're going to label your coordinates. So we have x1 and y1, x2 and y2. So we're going to plug all of that into this formula. So distance is the square root of, and you want to make sure and carry that square root bar all the way through so you don't forget at the end. x2 is -1. You always take the negatives with you. Minus x1 is 3. We're going to square that. Add it to y2 is -5. Y1 is -1 squared. Distance is the square root of, again, keep the bar. So now we have to clean up what's in here. I suggest using your calculator, because this is the stuff that we've kind of forgotten how to do a little bit, these integers. Remember, this says -1. So you're on the number line at -1, and you're going backwards 3 more. So that's -1 minus 3 is -4. We're still going to square that. And this is -5 minus 1 more is -6, and we're still going to square that. Now, distance and length are never, never, never negative. Anytime you square a negative number, it is positive. When you put this in the calculator, you must put it in parentheses. It must be parentheses, -4, close it, then square it. If you don't do it like this, you're not squaring it correctly. If you do it like this, that 2 is only going to the 4. It's not going to all of it. Very, very important that you make sure that you don't get those mixed up. All right, so -4 squared. Well, -4 times -4 is 16. This is -6 squared, which is 36. Then we're going to add these together. Distance is the square root of 16 plus 36 is 52. You can leave it just like this. I don't even need you to take the square root of 52. What this is referred to is when you leave it inside or underneath the square root bar, this is called exact form. It is actually a better form to leave your answers in because it's exact. We're not rounding it to some decimal version. If you do take the square root of it, that's totally fine. It's not a wrong answer. You're going to take the square root of it and you get 7 and some sort of a decimal. Okay, which is fine, but this is called approximate form because you're approximating what decimal to leave it to. I'm not telling you, so it's approximating. So exact form, approximate form. Thank you. Have a good night.